So now we have a queue data structure, and imagine that we wish to insert numbers from a given set. Let's insert number 1 and then number 7, then number 3. And what we're doing here is the inQueue method. Now, if we wish to remove elements from the queue, we will use the dequeue method. We must remove the first element from the queue every time. It was number 1, now number 7. Okay. And then we can inQueue again, for example. And when we do that, we must insert elements, inQueue elements, always at the end of the queue. And if we want to dequeue elements from the queue, we must remove the first element every time. That's a property of the vector queue data structure. And if we want to remove elements when there are none left, we get an error because the queue is empty. If we look from a perspective from left to right, we will realize that we're always inserting elements at the end of it and removing at the first position of it. We call this a lethal data structure, last in, first out. And if we make a time complexity analysis, we will see that both methods, inQueue and dequeue, are constant time complexity, because when we wish to inQueue an element, we must access the last element of the vector, and if we want to dequeue an element from the queue, we will access the first element from the vector, and we can do both of these operations in constant time.
So here's an implementation of the queue data structure in Python. First we have the class queue and the constructor method, in which we declare queue as an empty vector. Then there are all the methods related to it. The main methods: inQueue, in which we insert an element in the queue at the end of it; the dequeue, in which we remove an element from the beginning of the queue; the back method, that returns the element at the end of the queue; the clear method, that removes all the elements from the queue; the size method, that gets the quantity of elements in the queue; and the isEmpty method, that returns a boolean, and it will return true if the queue is empty, or false otherwise. So here's an example usage. First, we instantiate the queue class on myQueueObject. We use the method inQueue to insert number 1 in the queue, then number 3, number 7. Then we use the back method and return the element at the back of the queue and store it in this variable element on the back of queue. In this case, it will be number 7. The method dequeue, in which we will remove the first element from the queue and store it in this variable pop first element of queue. The isEmpty method, in which we return if the queue is empty or not. A boolean value that is stored in this variable is queueEmpty. And the size method, stored in this variable queueSize, that will return the size of the queue, the quantity of elements in it. And lastly, the clear method, that will remove all elements in the queue.